Question 9.19 says an intravenous solution contains 40 milliequivalents per liter of chloride and 15 milliequivalents per liter of hydrogen phosphate. If sodium is the only cation in solution, what is the sodium ion concentration in milliequivalents per liter? So I need to figure out how much sodium I need to balance out the negative charge of both the chloride and the hydrogen phosphate. So why don't I start with the chloride? And if I write down here that my chloride is 40 milliequivalents, 40 milliequivalents of chloride per liter, like that. Well, I know that I have one equivalent of chloride because the charge is 1 minus 1. So I have one equivalent of chloride in 1 mole of chloride, like that. And I know that for every 1 mole of chloride, so just based on the charges, if I have 1 mole of chloride Cl minus, I would need 1 mole of sodium plus to balance that out. And then I know that for every 1 mole of sodium cation, sodium plus, it has 1 equivalent of sodium because the charge is plus 1. So that means I have 1 equivalent of sodium ions in 1 mole of sodium ions. So if I look at what cancels out, I can see that equivalents of chloride will cancel out, moles of chloride will cancel out, moles of sodium will cancel out, and I'm left with milliequivalents of sodium per liter. So in this case, I'd end up with 40 milliequivalents of sodium plus per liter, like that. So if I try the same exercise, but this time with hydrogen phosphate, I'm going to start and I'm going to say, okay, well, if I have 15 milliequivalents of my hydrogen phosphate, HPO4 2 minus, per liter, I know that I have 2 equivalents because the charge is 2 minus. I have 2 equivalents of HPO4 2 minus in 1 mole. In 1 mole of HPO4 2 minus. Now, just based on the charges, if I had 1 mole of hydrogen phosphate, HPO4 2 minus, how much sodium would I need to balance that out? Well, based on the charges, if I had 1 mole of hydrogen phosphate 2 minus, I would need 2 moles of sodium cations or sodium ions to balance that out because sodium has a charge of plus 1 and hydrogen phosphate has a charge of minus 2. So I'm going to need twice as much of the sodium ions to balance that out. And then the last conversion factor I'm going to need is 1 mole of sodium ions has 1 equivalent of sodium ions because the charge is 1. So same thing as I did before. I can see that equivalents of hydrogen phosphate are going to cancel out moles of hydrogen phosphate, moles of sodium, and I'm left over with milliequivalents of sodium per liter. So I have 15 divided by 2 multiplied by 2, so I end up with 15 milliequivalents of sodium per liter, like that. So the question asks, if sodium is the only cation in solution, what is the sodium concentration? So the total concentration of sodium is going to be 40 plus 15 milliequivalents of sodium per liter. So it's going to equal 55 milliequivalents of sodium per liter. So that's going to be my final concentration. So it might be a knee-jerk reaction just to say, well, if I have 15 milliequivalents per liter and the charge is 2 minus, I multiply that by 2. Anyhow, I don't want to get into the mistakes that students make, but you have to look at the dimensional analysis carefully before you determine the total sodium concentration in this problem.